Alright guys, so this video is going to be a very short video, I hope, on just solving one-step equations. So let's go ahead and get started with that. I've wrote down 3 equations that I'm going to solve for you. I might talk about, actually I do need to talk about one other type, so let me see here. Let me just rewrite this before I forget how to do this. Okay. Alright, so 7 different equations that I'm going to solve for you guys. Alright, so the idea of solving an equation is that you are... So first of all, what is an equation? So an equation is when you have any expression, like say 3x plus 2, so that's an expression, equals some other expression. So maybe I'm going to write down some monomial, maybe like just 14 or something like that. And then the idea of solving an equation, what an equation is when you have an expression equal to another expression. And when you have 2 things that are equal, you can actually solve by moving things around and maintaining this equivalency. So what that equal sign is saying that 14 is the same value as 3x plus 2. So when you're solving, you have to maintain that same value. So for example, if I subtract 2 from this side like this, and I subtract 2 from this side, and you guys don't need to take notes, I'm just explaining what an equation is. The reason I subtract 2 from both sides is to maintain the same value. So let me go back. If this was the same value as this, then if I subtract 2 from the left side, it's no longer going to be the same value as 14. This side is going to be 2 less than 14. So in order to maintain equivalency, I need to subtract 2 from both sides. So now, this was the same value. If I subtract 2 from both sides, this is going to be 12. That means 3x is 12, and these are the same value. Okay, so that's why you get that saying, what you do to one side, you have to do to the other. That's to maintain equivalency. All right? So the idea is that you're balancing this equation. It was balanced. If I subtracted 2 sides, it's going to get lighter. This side's going to be heavier. Okay, so if you think about a balance, right? You want to keep it balanced the whole time. So what you do to one side, you have to do to the other side. And then in this case, I'd divide by 3. And if I divide by 3 on this side, I have to divide by 3 on the other side. So it still maintains its balance. Okay? That's the idea of an equation, and that's why you can solve them, all right? So today we're going to be focusing on one-step equations. What I just worked for you there was a 2-step equation. One-step equations, very, very basic. So the idea of solving an equation is you're trying to isolate a variable. So for example, let me write down an equation here. So if I have -2 equals 8 plus p. To solve this equation, I'm trying to isolate a variable. Say I'm trying to solve for p. So solve, in this case, I'm trying to solve for p. So I'm trying to isolate p. I'm trying to isolate a variable by using opposite operations. So for example, if I'm trying to isolate p and get p by itself, well then what's happening to p right now? P has an 8 being added to it, so p plus 8. So if I'm going to get rid of 8, there's an opposite operation to addition, and that's subtraction. So I need to subtract 8 from both sides. So real quick, if you're taking notes, I would just write down some opposite operations. So you have addition, and the opposite of addition is subtraction. So addition and subtraction are used for canceling each other out. You have multiplication and division are used for canceling each other out. Eventually, we'll get to the point where we're doing square roots and squaring things, or maybe a cubed root and cubing something. Those are opposite operations, okay? But right now we're just dealing with addition, subtraction, multiplication, and division. So if I see p plus 8, then I need to do, it's plus, so it's addition. I need to do the opposite, subtraction. I'm going to subtract 8 from this side. And what I do to one side, now I want you to keep all your work organized. So if you want, a lot of people put a line straight down the equal sign like this, and they work on both sides. So what I do to one side of the equal sign, subtract 8, I need to do to the other expression on the other side of the equal sign in order to maintain equality, right? So 8 minus 8 is 0, so those cancel. I carried the equal sign down. -2 minus 8 is -10. Okay? So notice I isolated a variable by doing the opposite, by using opposite operations. Okay? So I had a +8, so I did a -8. -8 on both sides, so I end up with -10 here equals p. And I've solved my equation for p. Okay? So that's one example. So everything before this point on the video was all explanation of exactly why we have to use equations, because they're equal, right? Two sides are equal to each other, to solve using opposite operations for a variable. Okay? Now I'm just going to work through a few more examples going quickly. So y minus 5 equals 2. So if I'm trying to isolate and solve for y, if I'm trying to solve for y and isolate that, then I need to get rid of a -5. So -5 is subtraction, so I need to do the opposite, addition. So I'm going to do +5 to both sides. So here's one side, there's the other side. Doing +5 to both sides. So -5 plus 5, that's just 0. So I have y by itself equals 2 plus 5 is 7. So I've isolated y. And the way to check this, actually, I would encourage you to do this, is you should be able to take whatever your answer is and go and plug it back into the original equation right here, and it should work out to be a true statement. So for example, this would be, if y is 7, then 7 minus 5 equals 2, which should be true. 2 equals 2, put a check mark and say, yeah, my check, it's right. Okay, you know it's right because you plugged it back in and you've proven it's right. Okay. Another one. 18 equals n plus 12. 18 equals n plus 12. So if I'm trying to isolate and solve for, n, then n plus 12, that's addition. Opposite of addition is subtraction. So I need to do minus 12 on both sides. So 12 and -12 cancel. So I have n equals 18 minus 12 is 6. N equals 6. So again, I can check that by, let me get a different color. I can check that by plugging that back into the original equation for n. So if n equals 6, then this original equation should be true when I put 6 in right there. So 18, let's see, 18 equals n is 6 plus 12. So 6 plus 12 is 18. 18 equals 18. Okay, and that works out. So you should always be able to check your answer by taking whatever it was and plugging it back into the original equation. All right, let's keep going with these. So those were 3 examples of addition and subtraction. Now I'm going to do some examples of multiplication and division. So if I have x divided by 2 equals 4, so again, I'm trying to, and I want to solve for whatever variable is there. Sometimes you have 2 variables. Right now it's just 1. So if I'm solving for x, I have x divided by 2. Okay, so the opposite of division is multiplication. So what I want to do is on both sides, I want to multiply by 2. Multiply by 2 on both sides. Let me write that in a different color. Okay. So I want to multiply by 2 on both sides. What I do to one side, I need to do to the other side. So if I multiply both sides by 2, well, 4 times 2 is 8. All right, so that's good. Now, 2 times x divided by 2, well, what happens with this 2 divided by 2 is it just turns into a 1, and 1 times x is just an x. A lot of people just say they cancel out. They do, okay? So they cancel out, you're left with just an x, and x equals 8. Now again, I should be able to check that by plugging it back into my original equation. So let's do that real quick. So if I'm going to check it, then I'd have x is 8. So if I'd have 8 divided by 2, 8 divided by 2 is 4. And 8 divided by 2 is 4 equals 4. So it checks out. Okay? A few more examples. Oops. I'm going to do h divided by 8 equals -10. h divided by 8 equals -10. Okay, so I'm dealing with division, so h is being divided, so I want to multiply, do the opposite, multiply by 8. H is divided by 8, so I'm going to multiply by 8 on both sides. Okay? So 8 cancels with 8. I have h equals negative 10 times 8 is negative 80. H is negative 80. So I should be able to check this by just plugging it back in and seeing if it works out. So if h is negative 80, then is negative 80 divided by 8, is that negative 10? If you don't know, just type it into your calculator. But yeah, 8 goes into 80 10 times. Negative 80 divided by 8 would be a negative 10. All right, so that all checks out. And then, let's see, 147 equals negative 21. All right, so here, negative 21n. So here I'm dealing with multiplication. So right here I have multiplication. The opposite of multiplication is division. So I need to use division to cancel this out. So I'm going to divide by negative 21 on both sides. Divide by negative 21. Remember, whatever I do to one side, I have to do to the other side to maintain that equality. All right, so I have negative 21 divided by negative 21. Well, that's positive 1n. And then let me get this calculator. 147 divided by 21 is 7. But it's a positive 147 divided by negative 21, so that's going to be negative 7. All right, so that's my answer. And if I wanted to check it, I could plug it all back in and see if it actually works out. So for example, 147, that's my answer right there. I'm done. But if I wanted to check it, I'd have 147 equals negative 21 times n is negative 7. Like that. And negative 21 times negative 7, if you type it into your calculator, is 147. So that works out. Okay, I'm going to do one last problem. This problem comes up a few times on your worksheet, so I wanted to go over it right now. So if I have 4 equals negative 13 minus m, and I want to solve for m, okay? I want to solve for m. Solve for m. I'm going to do the opposite operation. So right now, I have a negative. That's a little bit confusing. I have a negative 13. So notice I'm focusing on this negative 13 first. Okay. So to get rid of a negative 13, I'm going to add 13 to both sides. So again, opposite of subtraction or negative is addition. So I'm going to add 13 to both sides. So that's 17 equals, and then I'm left with negative m. Now, what's interesting is I have a minus m, okay? And what's actually happening there is, just an aside, you have negative 1m. That's what's actually there, okay? You could look at it like this, negative 1 times m, which gives you a negative m, all right? So to get rid of negative 1 times m, let's write it that way. It doesn't matter which way you write it. If you notice, I just wrote it 2 different ways. If you have negative 1 times m, then the opposite of multiplying is division. So you're going to have to divide by negative 1 on both sides. So divide by negative 1 and divide by negative 1 on the other side. So what we're doing here is we're dividing by negative 1, and you're dividing by negative 1 on this side. So 17 divided by negative 1 is negative 17. Negative m divided by negative 1 is positive m. Okay? So m equals negative 17. And I guess you can check to see if that is true. Let's go ahead and check this one real quick. So I have 4. 4 equals negative 13 minus, and then m is negative 17. Okay, so I have 4 equals negative 13 minus a negative, that's plus 17. So 17 minus 13, if you want to look at it that way, is 4. So 4 equals 4. Or if you have trouble with that, then you can use your calculator to type that in. You can do negative 13 plus 17, and you'll find out that it's 4. And it does work out. So we've checked our answer, and we are good. All right, guys. Well, I should be teaching this in class as well, but if you don't understand it in class, that's what I'm making this video for. So if you guys have any other additional questions, again, I'm here for tutoring Mondays and Thursdays.